So we presented a very similar presentation 3 weeks ago at the International Cyber Conference up at New York with the FBI Forum. And we're like, God, we can't come to SANS CTI and not present new stuff. So, new presentation. It's very exciting. Hidden empires of malware. Now, with blockchain and AI. Boom. This already 400% better than it was before, right? So we're done. Out. Cool. Yeah, PC. There we go. So before we do any talk, we like to go over what legal makes us say, which is don't buy stock on anything we say. Don't believe anything Dave says. We lean very forward, and sometimes we trip, as we'll discuss today. So with that in mind, we'll keep going. As said, I'm Ryan Kovar. Been doing cybersecurity stuff for 17 or 18 years now. I got my start in the US Navy, done everything from pulling Cat 5 on an aircraft carrier to working here at Splunk and traveling all over the world.
Yeah, I've worked at Splunk for a long time, about 3 years, been in IT for a long time. I'm a big advocate of SANS. I always love coming to these events. I'm a GSE, been through lots of SANS courses, been a SANS mentor. One thing that Ryan and I work on a lot is our boss of the SOC at Splunk, and sometimes people know us for that. So that's something that we've put a lot of effort into the last couple of years.
Cool. So agendas. This has come up multiple times. The who, what, where, when, how, why. I believe you've learned everything you need in just about under 6th grade, which is about my education level. So we're going to go over those now. So why are we doing this talk, right? What was so interesting about it? What are we talking about with hunting empires? It's a clever play on words that hopefully people find amusing. What are SSL certificates? A lot of people don't really dig into them as much as they should. I was converted by Mark Parsons' evangelism that we'll go over quite a bit today. What can you do with them, right? Now let's talk about the H's. How can I get the data yourself, and why should you? And how does blockchain, no, automate, nah, goddamn, what is, ML, machine learning, how can machine learning help you? And where do I get all this awesome stuff? But before all of that, I want everyone up. Come on. We're in the yawn phase. Come on, get up. I know it's awkward. I'm making you stand up. Shake it off. Shake it off. Get your inner Taylor Swift. There we go. All right. Keep standing. Keep standing. It's a clever ploy. We're going to have a counseling session, a little bit of come to Jesus, right? All right. If you don't know what SSL pivoting and hunting is, sit down. Oh, that's pretty good. That's awesome. Go ahead. Be honest with yourself or just be lazy. If your org can't capture SSL certificates at scale, sit down. Oh, that's pretty good. All right, finally. If you've never applied machine learning to SSL certificates, sit down. There's 2 people who should be standing, Rebecca Brown and Alex Pinto.
Yeah.
Oh my God, how surprising, right? You'll see why shortly. So, we have a lot of knowledge about things. We are consummate generalists of all the things, all the places, for everything, but we're not deep dive. With the exception of 2 people in the audience, neither are you, right? And that's part of what I like to do, is I think of it as bringing, like, I'm the little man going up to Prometheus and stealing some awesome cyber thunder and fire, bringing it down, right? We're trying to make this approachable for everyone, and we hope that you think that.
All right, so SSL certificates. So we know it's TLS, right? So the first question can be answered right away. Now, we just use the term SSL and TLS interchangeably for the purposes of this talk. And first of all, yeah, Mark, where's Mark at? Is he sitting over there? He is. So, yeah. So Mark has kind of pioneered this area of research. I know the first time I ever heard him talk about it over beers one time, I was just blown away at the insight that can be gathered through analyzing SSL and TLS certificates. He has a very long history of publishing all kinds of great tools and research talks on this topic, so you should check those out for sure. Also, as Rob mentioned, a lot of these techniques are being added into Forensics 578, which is a great class. We took it last year at this event. Just absolutely, for me, it kind of changed the world a little bit about how I think about, how I think about my own biases and how to try to eliminate those when I'm doing things like threat intelligence analysis. So highly recommend Forensics 578. So SSL certificates, we're not going to dwell on this too much because you most likely all know this, but they're small, right? These little artifacts, files, if you will, that bind some details about an organization to something like a subject, which is usually the common name is usually like a fully qualified domain name. There's lots of different varieties of these things. There can be self-signed certs. There can be certificates that are signed by a publicly trusted certificate authority or issued by an organization certificate authority. Suffice to say, there's a ton of detail in here that we can track and use to our advantage in the context of cyber threat intelligence.
So where can we get these, right? Like, you're not going to go and do a right-click on a certificate lock every 5 minutes or ask your users to do a lot of screenshots. And since this is a CTI conference, what we really want to talk about are giant repositories of frickin' data, right? Because that's what you guys are pivoting and hunting through. So the most famous, the most common, the one that Mark talked a lot about is census.io. It used to be completely free. They recently went commercial. Wonderful resource. Dave's going to go more into how they get their data and things along those lines. But if you use the free version, it's kind of weekly, bi-weekly scans that are updated, and you have access to search through them. Passive, or circle.lu, is kind of like the OG in the room for this. They've been doing it a long time. They're pulling SSL certificate information passively off their sensors. Passive Total, awesome tool, aggregation of multiple different sources, but you can do a lot of SSL pivoting and hunting in there as well. A lot of stocks use it. I love the tool. And finally, your own analysis platform, right? Bringing all this SSL data into your own SSL analysis platform. Whether you use Elk, whether you use Splunk, whether you use SQL, it doesn't really matter. A lot of different reasons for both, but actually bringing it in-house so you can do more advanced analytics.
Okay, so let's talk about the data source, and we're going to kind of advocate for the possibility you could create an analysis platform like this. The raw materials are the search results at the internet-wide scan data repository. It's also known as scans.io, hosted by the Census team, University of Michigan. That team performs a lot of scans and publishes those on that site. There's also a lot of data published on that site that's run by other organizations. We're going to talk about Rapid7 quite a bit here in just a minute. So how many people came to this conference last year? Okay. So I was here last year. I also spoke. I'm the guy last year that recommended that you violate the terms of service of a major internet site, and I gave you code to do it, in case you remember. So we're going to learn from that.
It's all about growth as people.
I'm still employed, and I still have my CISSP. My boss showed up this year to watch over me, though. So the data on this site is restricted to non-commercial use. So make sure if you're going to try any of these things that you are operating in line with all the posted licenses and restrictions on use. That's all on you. So let's talk about the sonar data. So Project Sonar is by Rapid7 Labs. Tremendous value to the community that they're providing. They run a lot of different studies. A study is like a type of a scan. One that we're going to talk a lot about is the SSL certificate study. We also pull in the HTTPS study as well and do some interesting things with that. That one's cool because it actually pulls down payload from port 443 on every IPv4 address on the internet. They have all kinds of other studies as well that you can check out. They have a separate license. So to my earlier point, make sure that you're doing everything in concert with the posted license and terms of service. And a big thanks to Rapid7. We wouldn't have any of this if not for them. So the SSL certificate study, sonar.ssl if you're accessing it programmatically, goes back to 2013. It's fairly, it's big, 315 gigabytes compressed, like when I pulled it down a few weeks ago, but 315 gigs is reasonable, right? It can be done. Grows a couple gigabytes a week compressed. We index it into Splunk. We work at Splunk, so we use Splunk for the platform, but you could do these things in any platform. But it's about 1.2 terabytes once we sort of expand it, decompress it, and enrich it a little bit with some of Mark's scripts. The key things in this study that we're looking at is, first of all, the observed certificates. So every certificate that's been observed as part of this study. Also a list of IP addresses and timestamps of when they were seen and on what IP address. There's also some other things that are distributed with that study. We won't talk too much about those right now. So this is after we sort of index all this data, right, this history of SSL certificates, TLS certificates, you can pull those up, and it's really actually quite interesting just to sort of browse the data. This is what a certificate looks like. It's got, the extensions and the public key and the issuer and the subject and all the things you'd expect to see there. One thing that actually that Mark put a lot of effort into as we were kind of looking through some of his code was tracking first seen and last seen date. Very, very useful. Aside from all the other stuff we're going to talk about, if all you do is sort of gain the ability to see when a certificate was starting to be used and when it was stopped, your last used, and on what IP addresses, that's a super valuable. It's just a very, very valuable use of this, and we'll show you some sort of concrete examples of that in just a second.
So that's the data. Those are the things where you can store it. That's how you can play with it. But what can you actually do with it, right? I like to break it down to knowns and unknowns, right? There's two things you can really do with SSL data as far as I'm concerned, and there may be more, but these are the two I'm aware of or I'd like to talk about. The first is when you're hunting down an incident, when you have a problem, when you have something going on in your SOC, right? And you have malware, you've had something that's connected to an external website that has an SSL cert. And you can get the SHA-1 hash of that, right? Now, we're vendors, so we don't necessarily have your data, your real-world data, so we're going to mock that up a little bit. We're going to use the SSLBL, so the SSL blacklist published by abuse.ch. We'll show up some links earlier. And you can think of this as just an open source repository of SSL certs that have been seen to do naughty stuff. And although we're not going to cover ACT or SAT at all today in our talk for once, first time, well, we will talk about our biases here. And you need to be aware the bias of this blacklist is it's almost all crimeware, right? A lot of you don't care about crimeware. You're dealing with nation states. But if you use this list, just be cognizant of that. It'll make much more sense here when we get to the machine learning part. So I'm going to pull out one of these SHA-1 hashes, right, GOSI Trojan, which nothing really special. It's pretty typical little Trojan, but it does communicate over SSL for its command and control in exfil. So I take that SHA-1 hash, and I go ahead and do a search in our analysis platform, right? And you could do similar in Census, and if you pay for the upgraded access, you can get more historical. But in this case, we're going to search through all 3 years against 160 million certificates and see what comes up, right? And immediately I see a couple results. 47 things pop up. So that's pretty interesting. Enhance. We go in, right? Let's dig a little deeper. So using that graph we saw earlier, we can see that in between 2 scan cycles, this SHA-1 cert was seen 46 other times on 46 unique IP addresses, and only during one week or 2 week period. Now, as a SOC analyst, as a TI guy, I look at this, and this is pretty damn suspicious, right? You have a cert that's only seen for one time ever. It comes up immediately all in the same day for 47 different IP addresses and then goes away, right? Your spidey sense is tingling. If you're in the middle of an investigation, you're adding this, you're pivoting, you're putting this in Maltego, and you're blowing up your graphs, right? The second use case, we always have to go back to Cybersfeld, Donald Cybersfeld, right? The known unknowns and hunting for there. So we want to find stuff where we know that bad people live in a place. How do we go hunt them down? In this case, we want to go hunt down bad TLS information. But we have to start with a focus. So we're going to pick on PowerShell Empire a little bit. And I got really interested in PowerShell Empire a while ago after working through an incident. For those of you not familiar with PowerShell Empire, a very bad explanation of it. It's kind of like Metasploit in PowerShell. But it's fun stuff. It's fileless. It runs. It's very heavily used by some adversaries and a lot of crimeware, script kiddie red teams. But the neat thing about PowerShell Empire, it's all on GitHub. Very nice gentleman created this out of Seattle. And you can go look at the code. And if you reverse the code, right, and actually look into it, you see a very interesting fact. One is that you can run PowerShell Empire with SSL encryption by default. Now, most people, like me, are lazy. So a lot of people just turn on that SSL switch, and then their PowerShell Empire is encrypted with SSL. What they don't look at and what they don't realize is all they're doing is running an SSL certificate generation with OpenSSL. And it has metadata hard-coded in there that you can start pivoting on. The primary being, one, that certificate is only going to be up for 1 year. And then two, it has a subject of C equals US, which is a little weird when you dig in a little bit. And you look at what a normal certificate is. So on the left and right is Splunk's certificate, and on the right, left are one of those directions. You have Google on one side and Splunk on the other. How about that? And those are legitimate SSL certificates that I've broken down into visual form. Now, the analyst is immediately drawn to the fact that one of these is not like the other, right? So let's do some more analysis on that. How can we find more things like that? So I'm going to do a search here using our analysis platform. Basically, the gobbledygook up there just says, find me everything that has a certificate of C equals US and nothing else, right? Because we saw that earlier. 2, I want to see if the website has returned a value of Microsoft IIS 7.5. Remember, Dave talked earlier, there's a sonar study that actually pulls back that information. So what we're looking here for is a combination of these two things, and it pulled back 245 events. Now, one of the reasons I'm really interested in this is PowerShell Empire primarily runs on Linux, but it has a web server that returns a value after a GET request of IIS 7.5. Very suspicious. So let's dig in, enhance. Run a quick script here doing an OS fingerprint against these IP addresses, and we find out the ones that are up and available, every single one of them is either running Linux or for some reason FortiGate, a next-gen firewall, right? So let's discard the next-gen firewall stuff. I'm okay with that. We're just going to dig a little bit deeper. Mark was kind enough to hand over a script he's used before, and I made some modifications. And what we do here is we're just going to tickle all the IP addresses that were up and had Microsoft as a return, or sorry, that were Linux. As we went through this, a lot were down, because remember, we're looking through 3 years worth of data, but 3 ended up coming back. What's very interesting about these 3 is the first one is a canary that I put in the very beginning of the data set, right? So that was my tester, and it came through every single iteration of my testing, that IP address came through. The other 2, I can't prove with a positive without going and sending some agents, but those 2 really do appear to be active PowerShell Empire on the network at the time of this research, right? I've talked to the PowerShell Empire developer. It's very difficult to actually dig in any further, but I'm pretty confident if I was running a SOC right now, those would be on a blacklist. So we went from many, many million, which is my math, to 3, which is pretty cool. But that was a lot of work, and that was a lot of research to actually just understand a single malware entity that I was looking at. There's other things been done for a couple other, like Puppy Rat, I think Mark worked on for a while. And there's other things like this that you can dig on, but damn it, it's hard work, right? So I was told there was AI in this presentation. No, but there is ML, and this is why this is going to be fun. But first, I apply what I call the Alex Pinto bullshit test, which is whenever I start thinking machine language is an answer to something, is it bullshit, right? Is it just a vendor coming through with machine learning that doesn't actually help or solve the problem? Is it actually machine learning, or is it just statistics, right? So keep that in mind. We did actually do a very rigorous Pinto test on every iteration of our analysis and research. So we'll go from there.
And now you're leaving it to me?
Yeah, you're all done. This is all your stuff.
Okay, this is our standard. We use Splunk, but you don't have to. We've mentioned it a couple times today. Everything we're going to do here is really nothing more than an application of Python scikit-learn. So again, you can use Elasticsearch, you can use whatever, but our examples use Splunk. Okay, so one of the things that we've done, we've been lucky enough to speak at a few of these conferences, as Ryan mentioned. We always like to try to bring things that we feel are useful and that are achievable, right, in most organizations. So we decided to apply a little bit of machine learning to this data that we had, and we're trying to achieve a certain outcome, which we'll share in just a second. This is not going to be the most advanced machine learning application that you've ever seen. We think it's an achievable one that might be useful to this audience. So if we start with this SSL blacklist that Ryan mentioned earlier, we actually have a list of things that at least some group of people who are somewhat trusted in some way, right? The people that publish the blacklist, they've said, hey, these certificates are bad, right? They're on the blacklist for a reason. And we have a lot of certificates that aren't, right? So we actually start to have this collection of labeled data, right? Things that are on this blacklist, things that aren't. So we started to ask ourselves this question: can we build a model that would predict inclusion on the blacklist? And if we could do that, more importantly, is that something that would actually alert us to something bad, right? Something that we didn't know about before that's valuable to us. So we kept this question extremely simple. This is our goal of going through this exercise. So we have labeled data. We can get the blacklisted certificates. We can load that into our platform as a CSV easily enough. We have lots of good certs to use as well, and we essentially have a labeled data set, right? Things that are on the blacklist, things that aren't. And this allows us, right, to start to think about supervised machine learning because we have some data that's labeled, so we can divide up that data and test, train on half of it, test on the other half, and then see if it actually does something useful for us. If you follow along at home, there's some searches on that last page that'll help you out in building some of those things. So one of the things that we did, starting out extremely simply, right? Again, not trying to split the atom with machine learning. We're trying to show examples of how it could be used. So one thing is we start out with a certificate on the left-hand side. It's kind of how a human being might look at that certificate. It's what I described earlier, issuer, subject, that sort of thing. We decided to extract some quantitative features from that, right? So numbers, right? Instead of using qualitative sort of categorical variables, which we could have used those as well, using one-hot encoding and things that more advanced sort of features like that in supervised machine learning. We kept it very simple. So this is actually the list of features. Super simple. We look at the number of certificate extensions, the number of elements in the issuer, the number of elements in the subject, the length of those things, the string length of extensions, issuer, and subject, and then we took Shannon entropy, which is a measurement of randomness of the common name that's in the subject. And I think there's some, yeah. So again, if you download this and want to follow along at home and try this out, there's some code that will help you generate all those things that I just described. And after we sort of selected those features, and there's a whole, we could do a whole talk on how to select features, right? So we could do principal component analysis, and we could do, all sorts of sort of measurement, right, of which of these features has the most impact on the outcome. We didn't do a ton of that, but that's where you would do it, right, before this step. The next step, selecting a model, right? So I mentioned earlier we use Machine Learning Toolkit from Splunk. It's a free app from Splunk, but it's just a wrapper around Python scikit-learn. Scikit-learn has a bunch of algorithms for detecting doing categorical predictions. So on a blacklist, not on a blacklist. That's a categorical prediction. So we ran through all those. One thing that we were really interested in was minimizing false positive rate and, of course, maximizing accuracy. So we had a few that were pretty close in accuracy, but one that was a clear winner on the false positive rate and the lowest false positive rate. And for the use cases we had in mind, we were a lot more worried about false positives than we were about false negatives, basically because we already have the blacklist, which is a list of all the bad ones, right? So the false negatives weren't as big of a problem for the use cases we had in mind. So this is the one that we selected. Yeah, this is what it looks like. And inside of the Machine Learning Toolkit, it has some of those metrics at the bottom. They're hard to read, but they're the ones we just summarized on the last page. Then we applied the model, which is an interesting thing. We're going to talk about a couple different ways you could use a model like this. One is basically just applying it to the corpus, right? This giant collection of SSL certificates that we had. Of course, that returns a huge result set, right? And true to form, it did just that. There was a bunch of certificates that were predicted to be on the blacklist that weren't. And if you go back to our question, right, can we learn something from that? Yeah, I mean, we can. So if we sort of wrote some scripts to go through those certificates that were predicted to be on that list that weren't. We pivoted to the IP addresses that we had from the sonar data. And then we just started looking for, are those IP addresses known to some other source to be bad, right? This is a very simplistic, right? Did some requests against VirusTotal, and we found a ton of bad stuff, right? Which sort of led me to believe that this is a viable, right? This is a simplistic but viable way to sort of meet that question that we asked of ourselves. So there's a couple ways that you would use this, right? And we're going to talk about that. I think now Ryan's going to talk about that.
So why do you care? It's a lot of math mumbo jumbo, right? And I'll be honest, I'm a simple boy from the mountains of Arizona, right? And what I'm used to is vendors coming up and saying, hear you, I got the solution for you right here. I say, we got the solution. Have you looked at our latest machine learning toolkit? My God, it can find all the cyber actors. It can find the APTs. It can find the TLS. It can find the satellites. Just come over here inside a PO, right over here with our local salesperson. That's kind of what I see a lot. That's kind of my gut feeling, being a former customer and an analyst, like a lot of the ML stuff, right? And I'll be honest, I ain't good at math, right? That's my first grade report card. Mrs. Johnson failed me in math. How do you fail first grader? It's like, how many fruit roll-ups do I have? 6? Oh, Mr. Kovar. So it's hard for me, right? Like, I struggle with math. I get the concepts, but putting 1 plus 2, I often get 6 or 7, or I end up with 6 apples. I don't really understand it. But is this approachable for us, right? Can we actually institute machine learning usably in our network without really complicated vendor mumbo jumbo? Or, like I said earlier, I want to take the IEEE papers, which are incredible, from about 10 years ago, frankly, and see if I can actually get them working in today's SOC and analyst platform. So there's 2 major ways that I see this working, right? 1, machine learning can add context to your events. If you ran that model earlier, right, 4%, now, we have 160 million certificates in our database. If we had 4% of those were false positives, you will be lynched by your SOC team, right? And rightfully so. That's way too many false positives. It's huge. However, I want you to change the paradigm, change the thought a little bit, right? You have a PDF that's downloaded. You happen to run Sysmon or Carbon Black. That PDF is executed and then contacts a brand new domain for the first time. Well, those 2 things, first off, a PDF I hate, so I'm immediately suspicious. 2, a PDF that goes off and pulls something from a foreign domain, or a different domain, that's weird. And then a new domain, that's super odd. Now, if you've been applying the model that Dave just talked about, and you have the machine learning model on there that says, hey, and by the way, that was an SSL encrypted session, and that certificate really matches our model for badness, you're going to set your Muellers on them, right? You're going to start your investigation. You should be interested in that.
That's Mueller.
That's Mueller. Mueller. Okay, let's mull over that for a second while we go to my next slide. Boom. All right. This is a cyber threat intelligence conference, not a computer network defense conference. So I want you to think about it in a different approach once again. We don't have a corpus of AP28 SSL certificates, but many of you probably do, whether you know it or not, frankly. But you may have that corpus in your network where you already have a whole bunch of things you can pull. So imagine a world where you create a model not based on a crimeware blacklist, which is going to have inherent biases towards crimeware, but instead create a model that's geared towards an actor that you're following, right? And suddenly, you go from 160 million to finding the bears in your network, much easier, right? I'm not going to stand up here and sell you a cyber snake oil, right? Machine learning doesn't solve the problem of cyber, but it can really help you find the bears in your network faster than you may have before. If you can go from 160 million to 8 million and then start applying different analytical tradecraft to that smaller data set, you're going to be way better off than you were when you started the day. One more thing.
Just one more thing. Oh, so yeah, if you want to build any of these things that we were showing you today, so that first link is a link to a presentation. It's a variant of this one, but it has a ton more about the plumbing. Like, this is how many servers you might need. This is how you run the code to download, download the studies and that sort of thing. The second link here is the code that will help you do a lot of that stuff. Gives you the ability to download the studies, which I think is useful, or even to sort of explore the size of them and things like that for planning. The bottom link there is a link to some code from Mark that we borrowed from heavily with permission, thank goodness.
It's all about those terms of service, baby.
That's right.
We're legal this year.
Service. So check those out. Good resources, hopefully.
Okay, let's wrap this up, right? Conclusion. I really hope you guys come away from this. We had a lot of you stand and said, yes, we know what SSL pivoting is. Go forth and do so, right? Look last year's presentation that Mark did. It really opened my eyes. It'll open your eyes. And then take it to the next level and say, how can we automate this? How can we find things that we've never looked for before, right? Don't be afraid of the unknowns. Like, at least I personally, we talked earlier about kind of lazy. We had the horrible image that Rick showed, right? I get lazy and I just do the same way of finding adversaries every day of the week, right? look at it from a different angle where you know nothing and you have a giant canvas and you have to start picking things through. Do that research ahead of time and start looking through. And finally, don't be scared of machine learning to reduce that data set. It is not going to always find the problem for you, and if it does, it's probably the wrong question you asked and has probably given you the wrong answer. At least that's my mathematical abilities for it. But you can do that and you can really help yourself out and your org. Special thanks, obviously, Mark Parsons, IKBD, Rapid7. We couldn't do any of this without their data and their niceness with their licensing. Census team at University of Michigan, and special call out to John Lankow and Laura Deason. John acted as our SOC analyst, and Lauren was the data scientist in a box who said, hey, you're probably not going to make a fool of yourselves if you say this.
Too late.
Yeah. Oh, well, should have said that first. But it was very nice of them to actually sit through our presentation and give us some critiques. I'm Ryan Kovar.
I'm Dave.
And thank you very much.